So we can start the daily brief back. Everyone. So this session will be the last session today at the closing of the working day of the sprint. And normally in this session, we give the participants an opportunity to share what they worked during the day or something interesting that they would like to comment or discuss with the audience. We have 3 tracks here, so I would like to ask if someone from each one of the tracks would like to summarize what they did during the day. So if there is someone here from Gimme, would they like to say a few words about what they did today?
But this is the reality.
So you did a tutorial, right?
Yeah. So we spent half of the morning discussing about what is Gimme, what is GeoIF, and how to do georeference. I haven't. Actually, I have no idea if it needs to be pronounced if or hif or heif, or I have no idea. Please, somebody told me, but settle down. I mean, the last time. So that's what we did in the morning. That then, of course, we prepared the presentation and went in that direction. Now we are starting to find out which are the best libraries that we could use to decompress the uncompressed codec that actually can have compression in broadly and in deflate and these things. We believe we found the right libraries and we are ready to try it. Meanwhile, I'm preparing a nice satellite image to also compress that into AV1 compression for tomorrow, that Nuria will also incorporate codecs, hopefully, and by then we will have an image to test. And that's more or less what we did.
Okay, so tomorrow we'll hear more about this, hopefully. And anyone else from that is working on Gimme would like to share anything? Even online? Okay, so yeah. Oh, yeah, thank you. Thank you. You're hiding behind the column.
Yes. So I was a bit like Ran. I was preparing for my tutorial this morning, so I was checking that the conformance testing tool worked in case I needed to demonstrate it, and that was useful to check the latest version. And then after the tutorial, I updated my slides with the spelling mistakes I spotted while giving it and other things. And then this afternoon, I've been looking at the other tools developed in testbed 21. So I was looking at libheaf, and I've just installed the QGIS raster importer tool for managing GIME files, because I'd like to be able to create a GIME file and then conformance test it.
Okay, thank you. Anyone else from Gimme? Yeah.
I'm not in any of the 3 themes.
That's fine. That's also fine.
But I think something that Sam mentioned that, by the way, I should say I'm Chris Little for those people online. The issue of time came up quite a lot in discussing of imagery, because not only does the spatial resolution of imagery increase, the temporal accuracy and precision at which you need to pin it down has increased, and we still haven't yet written down a best practice to make sure that your clock is the same as my clock, and therefore you can compare the 2 images and get a valid result. So I think that's a sort of a future issue.
Okay, thank you, Chris. Nuri?
We already prepared some images in GIME format, in H format. If someone want to use, is in www.ogcfree.grumets.cat/GIME.
Okay.
Is the-
So did you memorize this?
I can put in the chat. I
Yeah,
can
or
write in the chat.
Discord channel. Yeah. Okay, thank you. I think Sina wants to.
You mentioned that our requirement for time has changed. So GIME uses atomic time. And we are discussing this, that is it redundant or is it a good thing to have it? So I'll come over.
We have more microphones. Yeah.
That's exactly the kind of thing I recognize. So you may have your two atomic clocks, and at some point, when were they both calibrated against atomic time as issued by Paris? And of course, if you haven't calibrated it for a few days, you may be wrong by a few milliseconds, and that may be important, or a few seconds. Don't know. So how do you keep your own personal atomic clock in line? Keep it calibrated. How quickly does it drift? So all those issues. Just like when you get satellite imagery and you sort of overlay them on top of each other and say, oh, the coastlines don't quite match. I'll do a little fudge so they do line up. How would you do that in time?
So you're basically saying that the precision of that and the metadata about the time as well has to be incorporated.
Yes, and the process by which you fudge the time to say, okay, I've now coordinated the time. And therefore I can do a valid comparison.
I'm a complete ignorant about time, but nevertheless I will speak. Just to remind you that there are two things in GIME that were suggested. So you report the time, but you also report about the clock. And I believe those issues that you are talking about are contemplated there. Maybe we can review together tomorrow the actual parameters that they are saving to be sure that everything is there.
Yeah, okay, good.
Oh, okay, Lucio.
Just this morning, we were able to integrate the streaming of a video with MQTT to connect the system API Andreas developed and to retrieve the information. So this is working already, and what I'm working now is to have the metadata compatible with a Hive GIME. So to have something that is formally compatible with GIME and store this on our IPT service and blockchain.
Oh, I have more. I would have something for like 10 minutes if you are interested.
You want to show it now?
Are you interested? Yeah. Or no?
It is, but we are potentially.
Well, it is what I propose to work upon. So issue 181. What is everyone working on in this? Okay. Okay.
Andreas.
Okay. Can I share my screen?
Able to, yeah.
Not sure I want to do that, but yeah. Jesus. Why is it all so complicated? Why is it all so complicated? I cannot share.
So in the meantime, maybe we can.
I need to have it on the same screen, otherwise I cannot share.
Maybe we can check if anyone online was working on GIME. Maybe. No. We can see your screen.
There's something. Okay. So again, my work this week is on something totally uninteresting for everyone, which is IPT. It's totally of no one's interest, but I still do it. IPT. It's about intelligence and prototypes and beers. So no, IPT. So integrity, provenance, and trust, right? And I wanted to do something like the concept from testbed 21. Can that be applied to sensor data? Because we did it for EO data. And a simple question to me was, can we apply the concept to something like sensor data? And so I started thinking about it. Hey, it would be nice if you would now see my screen. It's so complicated. Why is all so complicated? I can switch the screen, right?
Yes, stop sharing and then let's. So
And now, share again.
that is, no, share the complete screen.
Yeah, here we go. So, testbed 21 solutions. Then the motivating use case for the sensor data stuff. Then the problem and the proposed approach. This is the first presentation today, now. Then I have more, like architecture and implementation approach and everything. That's potentially tomorrow. And hopefully on Wednesday, I have a tutti completi prototype solution for you. So part one, the sensor data stuff. So I hate this. Okay, so when you think about this IPT stuff that we did in the testbed and everywhere else, it's for binary files. It's for files, for any file. So we have been using solutions like verifiable credentials and blockchain, but it's limited to something like a binary file. And when you talk about verifiable credentials, there are basically two versions about it. So JWT, the JSON Web Tokens, you can stick that in catalogs. That's what Spacebill did. So they have digitally signed JSON in an API records catalog. You can use that anywhere else in disconnected environments, whatever, because it's self-contained. The digitally signed JSON is self-contained. The only thing that you need is a PKI in place. So you need some public key infrastructure in your disconnected environment, and then you can validate all the copies that are existing of these verifiable credentials, right? And potentially millions of those. The other solution is, that's what I implemented, is a blockchain-based immutable catalog. So basically the blockchain itself makes the JSON immutable. But you need to be online to verify. So you need to go to the blockchain to verify that your record is immutable. So verification is online. The good thing is you don't need PKI, right? In the disconnected environment, you need PKI. In the blockchain environment, you don't. In the verifiable credentials with JWTs, you can go in disconnected environments, but you need PKI. And the blockchain stuff, you need to be online, but you don't need PKI. So when you look at the testbed 20 and 21 result that I implemented, there is, to the left, there is testbed 20, that is DIDs, decentralized identifiers for IDs, so for identifying actors in the system. On the right-hand side, that is testbed 21, that's a provenance blockchain with a stack catalog on top of it. And the thing that I implemented was an OGC API process that blocked that watermarks an EO image, and it stores that thing on IPFS and the metadata record on the blockchain. So now the question is, can you apply all this? Question to me, can you apply all this to sensor data? Well, the motivation for sensor data is there's Sensor Things API. Who does not know about that? Good. Cross-check. Who knows about it? What's the difference? Why is it a problem? Why did I think about it? Why am I pestering you with it? What's the thing? No, wrong track. So it's a service, it's an API. There are no binary files. It's a database with an API on top. So you can use intelligent queries using OData protocol, Microsoft, thank you, to go and analyze sensor data that is stored in a database. Okay, so everyone who has access to the API and access rights can modify the data at any time. So the analysis that you do today, now, may not be the same tomorrow or in 5 minutes. So applying an IPT concept is it doesn't make sense because the data is not frozen. It's not a binary file on an IPFS or any other storage. So you need something to dump Sensor Things API into a file, right? And then you can go. So the question is, what can you do? So Sensor Things API, basically, what you need to do is first you need to create the data asset itself. Then you create an IPT and a quality enriched metadata thing that we did in testbed 21. Then you need to upload this data asset somewhere, somehow, and the stack item to the mutable catalog, and then you're there. So the critical mass here, the problem to start off with is this. Sensor Things API data model. Now, this is star plus, but you have figured that already, right? So if you dump this into a database, how would you tackle that? Yes, exactly. You would take the entities from the UML diagram as tables. Yeah, right. So what you do, you basically need to think about a proper format for your asset. Huh? So JSON and GeoJSON that comes out of Sensor Things API by default is not suitable. It's a JSON. Huh? It's a whatever. So now when you think about the queries that you can do, for example, you can do /observations top 100. That gives you 100 observations, right? So that is a JSON that only contains one entity, observation. Is that a proper database dump? No, it isn't. Because all the referring tables, all the referring entities that you would need to do the intelligence query on that dump are missing. So you need something that generates additional requests to the Sensor Things API endpoint to actually fill all the tables with some meaningful data. Is it possible? Yeah. And guess what I propose to use as a data format for the asset? GeoPackage. Who is here who does not know what GeoPackage is all about? Good. Okay. So GeoPackage, huh? The format invented by, who was that? Somewhere in Canada, huh? Yeah. Huh? Jeff something. Jeff Utzler, huh? So Jeff stuff, huh? So basically, I decided the data asset format that could be GeoPackage. GeoPackage is then the asset that contains a partial database dump. Partial because if you want top 100 observations, you do not need everything from the database. You just need those instances of the entities that are related with those 100 observations. So a little tricky, but maybe possible. So basically the idea is the data asset format is a GeoPackage. So I need to generate a GeoPackage from a Sensor Things API. So simple, you log in, you do your stuff, post your observations to the star plus endpoint. Once you have it in there, you need this, the box in the middle, Sensor Things API geopackaging service. That is the gimmick. So that you need to generate, you need to implement. Then you execute a query. That thing goes off into the star plus endpoint and generates your file. It goes on IPFS, and you generate your data quality and everything that goes on IP on the immutable catalog. So here again, right? So what does that service need to do? Basically, upload the geopackage into IPFS, generate metadata, and that goes to the blockchain. Where is that image of the blockchain? Okay, and then finally you can find it on IPFS, on the SEC endpoint. So very simple implementation approach. So you need that get URL into an instance of the right of the geopackage. So you need to fill the geopackage with some information. And this is where I am right now, implementing this geopackaging service. As you know, OGC API processes, who does not know what that is all about? Have you listed all these standards in the CodeSprint listing? So 1, 2, 3, 4. How many have I been using here? Four different four different standards. So API processes. 2 implementations exist that everyone knows about, right? GeoServer and PyGeo API. This autocorrect, I hate it. PyGeo API. This happens when you do things on British Airways flights, you know. It's a bump in the air and then boom. So 2 implementations. GeoServer is in Java and PyGeo API is in Python. So they both have their existence, their right to exist, fine. But I want an OGC API processes framework according to part 2. Who does know what the draft part 2 is in OGC API processes? Jerome, you know that. It's deploy. You can deploy your own process. So none of these GeoServer and PyGeo APIs support that you can deploy your own process, right? So I need to come up with something. And I thought, okay, I implement it myself. Right? I mean, process is just a framework. It's not much, right? It's not doing anything. It's just the container, the framework for something to happen. So the idea is Node.js plus asynchronous processing with BullMQ. So a queue, a proper queue system where your processes are queued. You can start them, you can stop them, you can introspect them, proper. And then, okay, the deployment, they give you 3 options in the draft. And one is Docker images. And that is what I implement. So basically what you will see as the first result is an OGC API processes implementation by Andreas that does proper use of the part 2 with deploy, where you have asynchronous support, where the processes go in a proper queue and they get worked on in a queue. There are real processes in the background. You can start them, you can kill them, you can do everything you want with them. So that is where I am right now. And more I will tell you tomorrow. Thank you. Assuming you have no questions. And now over a beer.
Two questions. Okay, going back to the slide where you said the problem is the database.
No, I didn't say
around the database. Okay, but you said anybody could alter the data and therefore that's the risk. Why can't you just transfer all your expertise to the issue of separating out right? Oh, I don't know. There's a second one. No, before that. Yeah, that one. Yeah. Why can't you just put all your effort into restricting write access? For most people, the observation database is read-only. Then problem nothing, right?
So, if you're interested in a real answer, research project.
Yeah, okay.
Study.
Okay.
1,500 pages. Why not? No. The conclusion basically is the reason. How are you going to constrain write access into an API endpoint where millions of sensors are posting observations,
Yeah.
1,000 a second? How are you going to organize and do that?
Okay. Accept answer.
I mean, I give you
You've answered my first question. Yep. You've shown it.
all traffic light in Hamburg.
Yep.
This thing, if you tap that, for example, you have
Yep.
millions, 10,000 of
Okay.
transactions per second. How are you going to constrain access? Right.
Okay, fine. Okay.
So
Answer the question. That's fine.
Here's my
Thank you.
work, done.
You can stop now. Thank you.
You can't. You can't. So it's not
Okay.
possible.
Okay.
So you clearly then, if you say top 100 observations now, in 1 second, it's no longer top 100, not the same stuff anymore.
Yeah.
So you-
Yeah,
so
I get it.
you
I get it.
You need to freeze something.
Second question.
Yes.
Does the slide before this,
Oh. Yeah, fancy back.
or before that even? I can't remember. Yeah, that one. Those two approaches. Post-quantum infrastructure. Post-quantum encryption. Can either of those be adopted to that? An awful lot of the current security protocols and encryption methods will be able to be cracked in the next 10 years. Yeah, well, that's why I'm asking, right? So, yeah, well, there are people who are proposing. I am not. I'm not even doing online banking, right? But people are proposing post-quantum encryption methods now. So which would be applicable to these two? Which would be most amenable? Don't know. That's fine. Okay, interesting question.
November ago and something, I was talking to SAP people, not SAP, the capital company in Germany. So, and I said, because he was in the blockchain session, and he said, blockchain information? Oh, he was going, what? This is Stone Age. We have already our blockchain stuff in here and there and everywhere. There's no blockchain included. No. He said, why is that? Good question. So before we talk about cracking options with quantum computing and healing stuff, then let's settle this. Okay.
Okay. Okay, any more questions for Andreas?
So for the long talk.
That's fine. So hopefully tomorrow you can show us some implementation. Oh, you already have some implementation to show. Because when you said you're going to show something. Okay. Yeah, and tomorrow you show us. Yeah.
I can show you tomorrow.
Okay. Okay. Thank you, Andreas. So, so maybe we move to the other track, GeoCML. I don't know, Kobe, do you want to summarize some of the activities, or maybe there's someone online? Okay.
Ernest, do you want to give us an update on your GeoCML work, please?
Were you asking for me?
Yes, please. Just a brief update on progress made so far.
Okay, sure. So today we created the first or a first draft of the JSON schema for GeoSciML basic application schema. We've pushed that into the Git repository that Gobi gave us. Because there was time, we also started work on schema files for the other GeoSciML application schemas, just to see what might be missing there. And that's where we identified some limitations, actually, because JSON schema implementations for some external types are missing. And I need to take a look at what's available tomorrow. So, for example, from observations and measurements, OM observation, SF sampling features, and so on. And also from ISO 9108, TM instant, and such. I have not actually looked too deep right now into which implementations might be available, but well, I have not found any ad hoc. And tomorrow, hopefully, I can get a hand on some experts to discuss technical questions around GeoSciML. So Gobi, if you're available, maybe sponsors or Steve, maybe, who was in the chat today, then we can discuss some of these things, make some decisions, and then hopefully I can draft documentation of the encoding rule for GeoSciML. We'll see. And another task for tomorrow, maybe, or the day after, is to craft some JSON encoded GeoSciML instance data and validate it against the JSON schema, and also be able to demonstrate some well, that this works or what the limitations are.
Okay, that sounds great. Thanks, Johannes. Any questions for Johannes or comments? Okay, yeah, regarding GeoSciML experts participating, so Ed Lewis will be participating online tomorrow. He was here in person today, but tomorrow he'll participate remotely. So that will be, you know, so he'll be a good resource as well for GeoSciML expertise. And I think is it Steve Richard as well? So he's also been participating. So I think we'll have quite a number of participants that can share their expertise on GeoSciML. Okay. Thanks, Johannes. Alejandro?
Hi, is this working? Okay.
Yeah.
So what I did today, I managed to create a script that and put that into a GitHub repo with a workflow that can take the existing GeoSciML code list, so the concept schemes, the semantic data, basically. Download that, remap the GeoSciML URIs so that we use the OGC namespace and the 3ws.opengis.net, and push that automatically to our instance of the definition server of our Rainbow. Right now, I'm using the development instance. That's what we have it for. And so the idea is that once we still need to check the outputs to see that everything is in place. We also add some SCOS exact match entries for the new resources that we're creating under the OGC namespace, so that we link those back to the original ones. And once it's ready for production, but for that we need to verify the URIs that they're actually correct and everything is in order. and that we get permission from the naming authority to use the proper actual ODC namespace for that, we can simply update the GitHub workflow to push data directly into production instead. Did I forget anything? Thank you.
Yeah, thank you. So any questions about the GSCML activities? If not, you can also reach out later to Johannes, Alejandro, and Kobe, and Mark. So maybe next we can go to the 3D tiles and GLTF track. Shan, would you like to summarize a little bit like the activities today?
Yeah, so me and Tam were working on basically coming up with a bunch of requirements for GLTF 2.1, like coming both from the 3D tile side and also the I3S side. So yeah, a few of those we're talking about coordinate systems, like whether those should be like supported in GLTF. And then we talked about a variety of other features. I think tomorrow we'll probably work on like starting some schemas for some of the extensions that we'll need. And then maybe on the last day, some code and prototypes. We also talked a lot about BIM use cases. So I think we'll mock up some examples of what that might look like in GLTF 2.1.
Okay, thank you. So if anyone else would like to share your work from today, you're also welcome, or comments. Would you like to say something?
Hi, everyone. My name is Iman. I'm the founder of InfraFund. So we are tokenizing renewable energy projects on blockchain, and we also providing digital twins from those kind of tokenized renewable energy projects for community members to check their progress and performance of those kind of renewable energy project. Today I came here to understand what is the difference between GLTF and 3D tiles, and I could have some insight about the difference, and also I understand some specific difference between AEC construction, architecture, engineering, construction industry, and also the smart GML standards like LOD. And we could have some great discussion about these areas, and also I could understand how to convert these 3D models of the BIM. As a BIM manager, it was really hard to convert this 3D BIM model into something very optimized on our web application. But right now, I am happy that I could understand those kind of converters based on the guidance that I got from Cesium. And also today I have created a sample 3D model of a wind turbine to convert this wind turbine to one GLTF format. And for tomorrow, we'll work on it to upload it on our web application and to see how it is optimized. But the most important area that we are focusing is about preserving those kind of metadata of this 3D geothermal, 3D model that we have, which is based on BIM. And after that, based on Cesium.js, we can bake that 3D model to something very optimized. And that is really important for us. And if we could have that kind of achievement during this code sprint, it could be very helpful and useful for us. Thank you so much for your opportunity.
Thank you. Okay.
Hi, and I am working on a open source simulation for the UK National Energy System, and I've had a few wonderful conversations today with Chris and Sam, So thank you very much. And also Jerome, who just happened to help me out a few weeks ago. In fact, you know, just I was quite amazed actually to see you here today. So thank you very much for all of your encouragement and advice about everything geospatial and funding. So thank you.
I can say what I've been doing. Yeah, so today I've been focusing on OGC API coverages, so trying to specifically address issue 225 about recommendation for supporting client preference for interpolation methods. So Francis had given us a lot of feedback that on the pull request that I had started. So today I tried to address all this feedback to try to finish this pull request, which is one of the last thing for OGC API coverages. So we're trying to finalize this. The next thing is the main other thing missing, I think, is the examples annex. We have like example requests and responses. So that's one thing we're trying to finish this week. Well, probably here I'll be working on other things, but we're extending the code sprint in Barcelona. So hopefully with Joanne and Nuria's help, we'll be able to complete this, because that's the one thing that we absolutely want to present to the OAB for at the Helsinki meeting. So that's trying to finish this, yeah. But yeah, tomorrow I'll be working on the Carter Sim, I think, and then also on the 3D Geo volumes. So that's the other things. Yeah,
it's good to revive the.
Yeah, exactly.
That standard. Yeah.
Thanks.
Do you want to say something? No? Anyone here in this family? Okay. What about you? Like to share something?
Yeah,
Your
FMSTI.
activities?
Well, today, as Joanne already highlighted, we had a long discussion on GIMI. That was one of the activities that I was involved in. But regarding the Federated Marine SDI, that was one of the topics for the lightning talks today. We discussed the another alternative format that we should look into other than the BAG. So BAG is the bathymetry format that has a very limited IPT included in it. So basically it lacks the precision information. The box for it, let's put it, is there, but the material is not supporting anything. So you cannot really get anything out of it. And the issue that exists in the marine domain is actually the issue of the connection of the marine domain to the land. The reason is that land has a different authority gathering the data, and the marine has different authority for gathering the data. So bathymetry and the DTM, the DEM from the ground, are most often not connected to each other. And you have zones that you called white ribbons around the shorelines that nobody gathers data. And this issue might have been ignored previously, but with the problems that we have with the climate, and most often these places get inundated or other things happen. This area right now is of the focus in the marine domain, and there are countries that gather different type of data to cover this. But still, the problem is that there is one datum for marine and another datum for land observation. So your zeros are not the same, let's put it this way. So in order to connect this to do these two together, you also have to consider the formats that the data is stored in. So one very dominant format these days, because of the S100 series standard by IHO, is BAG. And BAG, as I mentioned, does not really has a proper support for the IPT. And for land, you might want to use, that was highlighted today, DGXF, which is, both of them are based on HDF5 format. And DGXF has a better track for provenance and for the conversion between the coordinate reference systems and other things that comes in between. So it was suggested that we take a look into the DGXF to see if there is anything that we can support or suggest to the IHO family of standards of ISO 100, IHO 100, sorry, S100. So that's the update.
Thank you very much. Just to complete a little bit, DGXF is an OGC standard which was done, I think, 3 or 4 years ago. It's relatively new. It's a replacement for NetCon and NTV2, the data format that were designed for plate tectonic or this kind of change. So NetCon and NTV2 are two widely used formats for datum change. DGXF is a replacement for them, but it's tried to be more generic, and it covers also the case of a change of vertical datum. So it can be used for sea level, change between sphere and sea level, or change between the sea and the land and stuff like that. The DGXF format explicitly refers to EHO for that sphere and sea level. So it's really designed with that use case in mind among other use cases.
So is there someone online who would like to also share what they worked today? Let's check in the chat. Okay, if not, I think we can close the session for today. It was an extremely productive first day, I think. And tomorrow we'll be here from 9 a.m. We'll have the stand-up here at 10 a.m. So this will be the first event, and then we will have still tutorials in the other room during the entire day. So thank you for coming, and hopefully see you tomorrow. Thanks.